All right, in this video we're going to introduce properties of logarithms, and in this one we're going to look at just the properties themselves. In the next video we'll look at some examples of using these properties to expand logarithmic expressions. So exponents and logarithms have very similar properties. So first up we have what's known as our product property, and for exponents that means that if you multiply exponential expressions that have like bases, you end up adding your exponents. So b to the x times b to the y is b to the x plus y. With logarithms, a similar property says if we have log base b of x plus log base b of y, that equals log base b of x times y. So notice how in this one we take the log of a product is equal to the sum of the logarithms. If we multiply like bases, it equals the base with the sum of the powers. Our quotient property, on the other hand, says if we have two exponential expressions that we're dividing, such as b to the x over b to the y, that's going to equal to b to the x minus y. So if we're dividing the like bases, we subtract our exponents. With logarithms, log base b of x over y equals log base b of x minus log base b of y. So as we can see, with logarithms, the logarithm of a quotient is the difference of the logarithms, the logarithm of the numerator minus the logarithm of the denominator. With power property, that says for exponents, if we raise our exponential expression to a power, we multiply our exponents. So b to the x, that expression being raised to the y power equals b to the x times y. With logarithms, log base b of x to the y power, we bring down our power and we multiply it by the logarithm. So log base b of x to the y power, we bring this y power down in front and multiply. So we get y times log base b of x. Our equality property says that if we have two exponential expressions with like bases equal to each other, that's going to imply that the exponents have to be equal to each other. And x and y can be any real number. With logarithms, if we have the two equal logarithms with the same base, that's going to imply that the arguments here, x and y, are going to be equal, with, again, the condition for the domain of logarithms that x is greater than 0 and y is greater than 0. Now, I want to conclude this video by showing you how some of these properties of logarithms have been used in the past. And this is what's known as a slide rule. This is something that, if you've ever seen the movie Apollo 13, the astronauts use this to help, or the engineers at NASA use this to help get the astronauts in space. And this is what you did all your calculations on many, many years ago. So it operates under the principle of properties of logarithms. So for instance, with the product property, we said that the log of a product equals the sum of the logarithms. And you can actually use this to help you multiply. So for instance, if we wanted to take, let's say, 2 times 3, and there's a lot of different scales on here. You got a K scale, A scale, and all that. But for our purposes, we're just going to focus on this C and D scale. So if we wanted to multiply 2 times 3, then what we do is we take our slide, this is the slide part of a slide rule, and we're going to line this 1 up with either the 2 down here or the 3 that's over here. So we'll just do this 2 since it's first. So this will actually help us figure out what something like 2 times 3 is. And we can use this to help guide to our answer. So we have the 2 here. We have all these little 1s and 2s and 3s here, but the slide rules doesn't give you specific decimal place values. So instead, we want to use the larger numbers afterwards. We have the 2. We're going to move this all the way over to the 3 that's right there. And if we look below the 3, we get 6, which is our answer for 2 times 3 gives us 6. Division works the same way. If we did 6 divided by 3, we could line our 3 up with the 6 and then find where the 1 is on this scale, and 6 divided by 3 is going to give us 2. If we want to do 6 divided by 2, we could slide the 2 over to the 6 And then 6 divided by 2 gives us 3. So this is actually was used for a lot of engineers way back when would use slide rules because calculators either were much too expensive or much too large to be able to do calculations on the fly. They had giant machines that you couldn't just carry with you in your cell phone and smartphone like we can now. So, but that's how logarithms, properties of logarithms, were used to help design and achieve a lot of the things that we now take for granted. So, all right, that about does it for this video. In the next video, we'll take a look at some examples